Hi, this is Dr. Abdul, Physiotherapist. Welcome to my channel.
Human anatomy, bone cells. What are bone cells? Let's talk about in this video. Bone cells are the cells that make up bone tissues, which are nothing but compact and spongy bone tissues. An equilibrium between these bone cells maintains the bone tissue, and in turn this bone tissue makes up our bone, and this bone makes up our skeleton in place maintained. So that's the importance of a bone cells. Bone is composed of four different cells type that are osteoblasts, osteocytes, osteoprogenitor or also called as osteogenic cell, and osteoclast. Let's see one by one what is osteoblast. Is the bone cell that responsible for forming new bone, is found in the growing portion of bone including the periosteum and endosteum. Osteoblasts, which do not divide, synthesize and secrete the collagen matrix and calcium salts. As the secreted matrix surrounding the osteoblast calcifies and the osteoblast become trapped within it, as a result it changes in structure, becoming an osteocyte. The primary cell, the osteocyte, is a primary cell of mature bone and the most common type of bone cell. Let's see what is osteocyte is. Osteocyte is located in a space called lacunae surrounded by bone tissue. Osteocytes maintain the mineral concentration of the matrix via secretion of enzymes. As in the cases with the osteoblasts and also osteocytes lack mitotic activity. Both osteoblasts and osteocytes lack mitotic activity. They are able to communicate with each other and receive nutrients via long cytoplasmic processes that extend through canaliculi, a channel within the bone matrix. If osteoblasts and osteocytes are incapable of mitosis, then how are they replenished when all cells die? So answer lies in the properties of third category of bone cells. Yes, the answer lies in the properties of a third category of bone cells, that is nothing but osteoprogenitor or osteogenic cell. Let's see what is it. Osteoprogenitor osteogenic cell. These osteogenic cells are undifferentiated with high mitotic activity. They are the only bone cells that divide. Immature osteogenic cells are found in the deep layers of the periosteum and marrow. When they differentiate, they develop into osteoblast. The dynamic nature of bone means that a new tissue is constantly formed while old, injured or unnecessary bone is dissolved for repair or for calcium release in the blood supply. Osteoclasts. Osteoclasts are responsible for bone resorption, as in case what we have seen, how the calcium is released and how the bone repair takes place. So osteoclasts are responsible for bone resorption or breakdown, which is found on bone surfaces. It's multinucleated and originates from monocytes and macrophages rather than from osteogenic cells. Osteoclasts continually break down old bone with while osteoblasts continually form new bone. I repeat once again, osteoclasts continually break down old bone with the need of the calcium or for the repair and remodeling of the bone, while osteoblasts continually form new bone. The ongoing balance between osteoclast and osteoblast is responsible for the constant but subtle remodeling of bone. When you see the cut section of small piece of a bone under microscope, you will find an amazing interconnected crisscross structure, crisscross matrix structure. Let's see what it is. It is called Haversian systems. A cut section of a bone, a long bone you can see over here in the diagram, and this is nothing but a compact bone consists of closely packed osteons are called Haversian system. So this is a compact bone, a cut section of compact bone, and this is Haversian system, which has this central canal called the Haversian canal, as you can see here, and which is surrounded by concentric rings of matrix called lamellae. Like this, if you remove it from that cut section, it will look like this, lamellae. Between the rings of matrix, that is lamellae, the osteocytes are located in the space called lacunae. This is osteocytes in the space called lacunae. Small channels, which are called canaliculi, radiate from the lacunae to Haversian canal to provide passageway through the hard matrix. Here you can see this is called canaliculi, which are interconnected, crisscross each other. And this Haversian canal contains blood vessels that are parallel to the long axis of the bone. As you can see here, they contain the blood vessels and nerve. These blood vessels interconnected by a way of perforating canal with the vessels on the surface of the bone. So they are interconnected, and also on the surface they are connected. Thanks for watching.
Follow me at YouTube, Facebook, Instagram, and for any business related inquiry, contact me at dr.abdul.pt@gmail.com.